Hello everyone, I'm Steven from Tech Overseas, and I have recently noticed that there has been a lot of confusion when it comes to JavaScript promises, especially amongst junior developers, and really it shouldn't because they are much simpler than we think. And so that's why in this video, we are going to take a deep dive into JavaScript promises. We are going to check what they are, how they work, and I'm going to give you some advanced tips and tricks on how to master them. So let's jump right in. Promises actually allow us to deal with asynchronous operation. So you've probably heard this before, asynchronous versus synchronous, blocking versus non-blocking. What does it even mean? Imagine a promise like placing an order on Amazon. Now picture you have a friend coming over and you want to order something very quickly before getting ready. So in a synchronous or blocking scenario, you would actually place an order and just sit there by the computer waiting for the transaction to complete. There is nothing you can do until you know the result of the transaction, whether it's a success or whether it's a failure. Now, in an asynchronous or non-blocking scenario, you would actually place the order, get a shower, get ready, do whatever you want, okay? But the idea is that you would continue with your tasks without waiting. And later on, you can come back and check the status of the order. So in order to create a promise, we have to use the promise constructor. And the promise constructor actually takes a function which has two parameters, resolve and reject. Now let's go ahead and create a very simple promise. So let's say constant promise equals new promise. Also, as you can see right now, my code editor is actually trying to autocomplete the code. And this is because I'm using GitHub Copilot. So I found that throughout all my project, GitHub Copilot has been pretty good. It has saved me a lot of time. It's pretty good at code autocompletion, a bit less at code suggestion. So I wouldn't trust everything that GitHub Copilot suggests to you. So let's go back to our very simple example. Let's say constant is success equals true. Now let's say if is success, we resolve. Otherwise, we reject with an error. And so this is how you create a very simple promise. You either resolve or you either reject. Now, in order to use and consume this newly created promise, there are three methods: .then, .catch, and .finally. So .then actually handles the success scenario and it takes a callback function. And this callback function has the resolve value as a parameter. .catch is a bit similar, but it actually handles any errors that might occur. It also takes a callback function, and this callback function has the rejected value as a parameter. And finally, .finally, it runs regardless of the outcome. So it also takes a callback function, but the difference is that .finally does not take the value as a parameter. It does not take anything as a parameter. Think of .finally as a cleanup function that runs once the operation has completed. Now let's apply these three methods and see how it looks like. So promise, let's say .then. I'm going to change this to value. It will be important after. Now let's say .catch, console log, and let's say we have our .finally. So let's just clean up this, then, and catch. So now as you can see, our promise actually resolved because is success is true, and it prints then success and the finally. Now if we put is success to false, you can see that it's being caught in the .catch, so catch error, and we have the .finally. One of the powerful features of promises is actually promise chaining. So it allows you to execute multiple asynchronous operations in sequence. Now let's take a very simple example. Say that we are going to remove all this code, say that our first promise actually resolved the number 100. It's not really important, but let's just take numbers so it will make more sense in the example. Now in our first promise, we are going to return the value times 2, and we are going to create another then block when we are going to console log the newly created value. So we are going to say then 2 and we are going to say then 1. So now what's going to happen, this promise is actually going to resolve 100. The second promise is actually going to console log the first value, so 100, and it's going to return the value times 2. The third promise will actually console log this newly created value. So the result should obviously be then 1 100, then 2 200. Now in order to showcase promises properly, let's refactor our promise and let's introduce a delay of 3 seconds in order to simulate an asynchronous operation. It's kind of like waiting for some data to be fetched. So let's just change this and say set timeout. Okay, so we are still going to resolve 100 after 3 seconds. So now what's going to happen, if I save, you're going to say that it will take 3 seconds for the first console log to be printed out, and after it will just follow in sequence. So in this example, the first dot then is actually called once the first promise resolves. Now we can also chain the promise again and introduce another delay of 3 seconds. So you can see right now we return the value times 2 as a number, but we can also return a new promise. So we can say return new promise. It's going to also have the timeout, let's say this time of 1 second. And let's say that we are going to say value times 2. So now what's going to happen, I forgot to close this. Cool. So now what's going to happen, after 3 seconds, the first dot then will print, and after another 1 second, the second dot then will actually print, and then finally will print straight after. Something important to note is that dot then will run in sequence always, unless one of them throw an error. And so talking about error, there are actually 2 ways to throw an error. We either reject the value or we actually throw an error. So let's just try it out. So let's say that our second promise will actually reject, and it will reject error. So now in our case, the first promise will resolve the number 100, but the second promise will actually reject after 1 second. And so this dot then block should not be triggered, and we should immediately go in the catch block. So let's just save. So 3 seconds, we have dot then number 1, and after 1 second, we have the error. Now the second way to actually throw an error is by simply throwing an error. So we can remove the promise and we can say throw new error, and we can say error in dot then 1. And so again, in the flow, the promise will resolve after 3 seconds, will resolve the number 100. And in the first dot then block, we are going to throw the error, which will be catch in the dot catch. So let's just save and see how it looks like. So 3 seconds dot then, and then immediately it's going to error out in the first then. So the same thing goes with the dot catch. Only the first one will run unless it throws an error. So we can actually chain the dot catch. So let's go ahead and add a new catch where we say console log catch 2, and we actually have the dot catch here. So now if I save, nothing will change because simply the second promise will actually throw an error, and it will be caught by the nearest dot catch. So if I save, you will see that after 3 seconds, 100 is being printed out, and we have catch 1 errors in then 1. But what if we want to actually trigger the second catch? So if we want to trigger the second catch, what we can do is we can either just say throw error, because the error in the dot catch is of type error, so you can throw it immediately, or you can just say, for example, throw a new error, and you could say something like error.message, or you could say just error, it doesn't matter. So let's just say that we actually throw the error. Now, after 3 seconds, it will print 100, and then we have the first catch and we have the second catch. So this is actually very handy when you are in a scenario of data fetching and things like this, where in the dot catch, for example, you can say if the error is an instance of this error, I throw the error again, otherwise I can return undefined, for example. There are multiple things that you can do like this, and that's why it's very convenient to have the promise chaining. Now let's talk about async await. Async await allows us to write asynchronous code that looks and behaves like synchronous code. It's just syntactic sugar in order to make it easier to read and understand. So we can actually use await to pause the execution until a promise is resolved. So before we continue, there are actually 2 ways to create an asynchronous function. So we can create a function that returns a promise, or we can create a function with the async keyword. So let's go ahead and remove this code, and let's create our first asynchronous function. So the first asynchronous function, it's actually a function that returns a promise. So let's say function return promise, and then, and then we are going to return our promise. This is the first way to do it. And the second way is a function with the async keyword. So let's go ahead and have async function. and we're going to say, yeah, return async function. We are not going to return this. We are going to return, for example, the number 100. And so here you can see that the function returns a promise returning the number 100. And let's say I'm going to do console log of async function. You can see that in the console, it's actually printing out a promise. It's not printing out the number 100. And this is because an asynchronous function is actually a promise. So no matter what you return, whether you return a promise or you return, for example, you can return a string which says success, it's actually going to resolve as a promise. Now let's remove all our code and let's create a realistic scenario from our initial example with the friend coming along and you want to place an order before getting ready and so on. So let's say that we have, for example, constant place order, which is going to be, it's going to be an asynchronous function. It's not going to take anything. Let's say that we are going to return a new promise with result reject, and we are going to say set timeout. Yeah, so the order is placed successfully after 3 seconds. Okay, so this is our placeholder. Now we are going to have constant prepare for friend to arrive. I'm not really inspired. This is also going to be an async function, and so in this we are going to console log preparing for friend to arrive. We are going to await place order, and we are going to say order placed successfully, something like this. Okay, like this. So now we have our place order, which will be triggered after 3 seconds. We have our prepare friends to arrive, which is a function which actually preparing for the friend to arrive. We pause to place the order, and we have the order placed successfully. So actually we don't need to have anything in resolve here because we already have the log here. Okay, so now let's say that we want to run this, and we have console log starting getting ready for friend to arrive. Now we have prepare friend to arrive, and we have ready for friend to arrive. Okay, so, or let's say showering and getting ready. Okay, so in this case, it might seem like the code is pausing, but what's really happening is a bit different. So when JavaScript actually hits this await, so the await place order, it will immediately returns control to the main thread. And so this means that the main thread can continue running the code while the async function is waiting for the promise to resolve. So in this example, okay, it's pausing the function, but the main thread is free to handle other tasks while place order is pending. And this is very important because now if I save, you will see that we have start getting ready, preparing for friend to arrive, showering, and after everything, the order was placed successfully. So we didn't wait for showering or preparing for the friend until the order was placed successfully. The order was placed successfully afterward. Now, we have seen previously how to handle errors using the dot catch. However, handling errors using async await is usually the preferred solution. And this is mainly because it's easier to read, it's easier to understand. So let's go ahead and refactor our prepare for friend to arrive, and let's use a try catch block. So let's go ahead and have the try catch. Let's move the logic in the try, just like that. And let's just console log our error. So now I save, as you can see that nothing will change, and this is mainly because the place order actually resolves after 3 seconds. So we have start getting ready, preparing, and so on, and we have order placed successfully. Now what happened if I actually reject? So if I reject and I say order failed to place, if I save, it's still not blocking the normal flow of the application, so I still get ready, I still prepare for friend to arrive, and so on, but the order failed to place afterward without blocking the actual execution of the code. So now let's say that you actually want to place multiple order before preparing for your friend to arrive. So let's go ahead and create multiple orders. So let's go ahead and create 3 orders. So for the simplicity and in order to log everything, we are going to assign result1 for this, and we are going to duplicate this, result2, result3. So let's go ahead and say so log result 1, 2, 3. Okay, so now we are just going to randomize a bit our place order function, so it sometimes resolves, sometimes rejects. So let's say something like if math.random above 0.5, we are going to say result order placed successfully, and otherwise we are going to reject fail to place the order. So let's not say 0.5 because I guess it will fail most of the time. Yeah, let's do it like this, and let's change our orders placed successfully. Let's save. So now what's happening, we are still getting ready, we are still preparing for friend to arrive, but the actual prepare for friend to arrive function is actually running in sequence. So first we are trying to place the first order, we are trying to place the second order, and we are trying to place the third order. So let's save again to see how it actually triggers. So we can see that the first one actually placed successfully, the second one placed successfully, and the third one was placed successfully, and after we have our log orders placed successfully. That's how you can run them in sequence. But let's be honest, it's not really convenient to have the code running in sequence like this, and this is mainly because considering the place order actually takes 3 seconds to complete, we will have to wait 3 seconds for the first, 3 seconds for the second, 3 seconds for the third, and so on, and it just adds up. So that's why in promises we have some utility function. So we have 4 utility function, we have promise.all, promise.allSettled, promise.race, and promise.any. Now let's start with the first promise type. So let's say console.result, promise.all, let's remove all this. Let's actually console log the results. So what you have to know about promise.all is that it will wait for all the promises to resolve or for one to reject. And so if they all resolve, it will return an array of the result value, which is order placed successfully. And if one reject, it will actually throw an error with the failed to place order error. So let's just check this out. So I just save and I can see that I have failed to place order. I save again. I should see I have an array of string. So now I have an array of string of order placed successfully 3 times. Now let's check in the case of a rejection. Let's check, for example, which one rejects. So let's have plus index, and let's pass an index for all of them. So 1, 2, and 3. So let's have a fair one. Let's say 0.5. Now we can see fail to place order 1, we save again, fail to place order 2. So whenever it fails, it will actually reject the one that's failed and it will catch it in the console log.error. But the thing is, it might not be something that you want to do, because maybe you want to actually catch the one that succeed and catch the one that errored out. And in promise.all, we actually don't know which one succeeds if one of them rejects. So there is another method which is called promise.allSettled. And so promise.allSettled will actually wait for all the promises to settle, either reject or resolve before returning. And this is a very convenient scenario. So let's say, for example, that we have here place order 1, place order 2, place order 3, and one of them rejects. So when one of them rejects, it will be returned in a reject object. So how does it look like? So the fulfill object has a status of fulfilled and it will have a value. And the value is the actual data that is passed in the resolve. And the reject object will have a status of rejected and it will have a reason for the rejection. And the reason is the actual data, let's say, that is passed in the reject. So let's say this in practice. So let's save and let's see how it looks like. Now we should have an array of 3 objects. And you can see that they are all fulfilled. And so when they fulfilled, we have the value that is order placed successfully. Now let's save again and let's try to have some rejection. If one of them reject, we should see status rejected and we should see the reason, which is the actual data that it has here. Now to show you that it's any data, let's put an object here of the message, which is order placed successfully. Let's just also put the index. So let's just say index. And in the rejection, let's just do the same thing. we're going to have index and message order failed. Now, if I save, we will no longer have a string in the value or the reason, we'll now have an object. So you see, this one has been fulfilled and the value is actually the index and the message. This one has been rejected and the reason is the index and the message. And so promise.allSettled is probably the utility function I use the most, and I probably use it in 99% of the cases. Also, one of the big advantage of promise.allSettled is that whenever one rejects, it will not throw the whole function. It will actually catch the rejection smoothly and it will return to you an object with a rejection. Whereas promise.all will actually throw the whole function and it will put you out of the function execution, which is maybe not something you want to do. So another utility function is actually promise.raise. So promise.raise will resolve or reject as soon as one of the promise actually resolve or reject. Like the name implies, it's a race. So let's actually check this out. So let's say we are going to randomize the function execution of up to 3 seconds, okay? So let's pass the time and the time here, and let's change the set timeout time of time, okay? So something important to note also is that promise.raise will also put you out of the code execution, because when it rejects, it actually throws an error, and so you will end up in the catch statement here. So let's just save and let's see what happens. So you can see that here, the second promise was actually the first one to resolve, and it resolved in 369 milliseconds. Now let's save again, and you can see the third promise was actually the first one to reject, and it rejected in 108 milliseconds. So the first one, which will resolve or reject, will actually be the one that will be printed out in the console log here. So the last utility function is actually promise.any. So promise.any is actually the opposite of promise.all, because promise.any will resolve as soon as one of the promise resolve, or it will reject if all the promise reject. And so let's see this in practice. Let's see that we have here promise.any, and let's see that we have a big chance of having a resolution. So now let's save, and you can see that as soon as one of the promise resolve, it will actually resolve. Now let's say that we want all of them to reject. You can see that we no longer have the data that is passed in the reject here as an error. We have an aggregate error. So aggregate error means that all the promises were rejected. So today we covered a lot about JavaScript promises. We actually started with the basic understanding of asynchronous versus synchronous operation and how JavaScript promises actually work. We then explored how to create and use JavaScript promises with methods like .then, .catch, and .finally, and we also saw how powerful promise chaining can be for handling multiple asynchronous operations in sequence. We also introduced async await, which allows us to write asynchronous code that looks and behaves like synchronous code, but in a much more readable and easier manner. And finally, we looked at handling errors gracefully with try-catch blocks in an async await function, and how to manage multiple promises concurrently with promise.all, promise.allSettled, promise.raise, and promise.any.